All right, so this review is meant to help you with a quiz if you're in my class that deals with inverses, composition, and operations of functions. So what I'd like you guys to do right now is we're going to start with inverses. All right? We are going to do 3 different inverses of functions. The first one I'm going to call f of x equals, let's say, 7x minus 3. So that'll be a linear inverse. The next one we're going to do is we are going to do, I'll make it g of x instead of f of x. G of x, and this will be a quadratic, so I'm going to put x minus 2 in closed parentheses squared plus 5. So we have a quadratic. All right, this one's linear. And the last one that you could possibly see that's going to be on the quiz is a cubic. So I'll make that h of x. And that will be x, we'll put x plus 3 squared, and I'll just put minus 7. So what I'd like you to do right now in your journals is write that we're doing an example for a linear inverse, we'll do an example for a quadratic inverse, and we'll do an example for a cubic inverse. All right? Now, in this quadratic inverse, we are going to restrict the domain. All right? So I want you to understand, we're going to restrict the domain where x can simply be greater than or equal to the number 2. So we're going to restrict the domain to only the domain where x is greater than or equal to 2. And when we get to this inverse, I'll explain why we had to restrict the domain. And I meant to put 3 over here. My apologies. I'll put 3. There we go. To the power of 3. That's cubic. My apologies. All right, so we're going to start out with the linear inverse. So the first thing I like to do is f of x, I like to make y equals. So we put y equals 7x minus 3. Okay? On this one, I'm going to put y equals parentheses x minus 2 squared plus 5. And over here, I'm going to put y equals x plus 3 to the power of 3 minus 7. So all you're doing on each one of them is you're changing any of the function notations, whether it's f of x, g of x, or h of x, you're just changing all of them to y equals. Okay? Now, I'm switching colors now because now we're getting ready to solve for the inverses. So I'm going to switch my x and my y values. I just want you, the reason why I'm doing it kind of like all at once is I just want you guys to see that it's the same process. Okay? I'm just hoping your brain sees the pattern that I did the exact same thing whether I was solving for a linear inverse, a quadratic inverse, or for a cubic inverse. All right, so I'm going to go ahead and move down a little bit so you guys can see this a little bit better, have a little bit more room to work. Now, when you're solving for an inverse, you're at this point, after you've swapped the x and the y values, okay, after you've done that, you need to now solve for your new y. That's what you're trying to do. You're trying to solve for your new y. So if I'm solving for y, what would I have to do? I got to get rid of this, negative 3. So what am I going to do to both sides? I'm going to add a 3 to this side. I'm going to add a 3 to this side. Now, you can't combine those because those are not like terms. We're just going to leave it as x plus 3 equals 7y. So I'm going to rewrite it right here. 7y equals x plus 3. Now, you're going to get a couple of possible answer choices. All right? The last thing we're going to do is you probably notice that we could just divide everything by what? Divide everything by 7. And so you could get the inverse, we write it like this, the inverse of our original function is x plus 3 all over 7. And that's one possible answer. That's an equivalent answer to our inverse. But you could also see it like this. If I can write it, you can see it. Let's try it again. Here we go. Now, another way of saying x divided by 7 is 1/7 of x. And another way of saying 3 divided by 7 is saying plus 3/7. What I need you guys to understand is these right here. These mean the exact same. These are equivalent equations. All right? equivalent functions. They just look a little bit different. So I want you to be able to see that. All right, so let me explain to you what we're going to do in the next one. The next one's a little bit more complicated because it's quadratic, okay? So what I'm going to do is I'm going to type this into Desmos. I'm going to type this into Desmos. Just watch what I do here. I'm going to go here. I'm going to type in g of x equals parentheses x. Let me take a look at it real quick. X minus 2. And we're going to put squared. And was it plus 5? Do we have plus 5? Okay. Now, do you guys remember where I said I restricted the domain? This is where I'm going to restrict the domain. So check this out. I'm going to restrict the domain to where it's just x is greater than or equal to a 2. So I'm going to zoom out a little bit so you can see that, okay? So we're not doing the whole graph. Because honestly, listen, you can't... I want you guys to see why we're restricting the domain, okay? So there's the whole graph. If I try to find the inverse of it and I switch the x and the y, which this is the first step that we're going to do, okay, that I think we've already written down. Does everybody understand that this inverse right here, this is not a function? So what did we have to do? We have to restrict the domain so that we can actually find the inverse. So can I find the inverse of just that half? I can, because does this pass the horizontal line test? We talked about the horizontal line test. So I restricted the domain. So if you're wondering why in the world did I put x is greater than or equal to 2, is I'm trying to restrict the domain so we can actually solve for it. So that's why I said x is greater than or equal to 2. All right, so let's go ahead and solve for this inverse. So once again, first thing we're going to do is isolate the y values. So we're going to take away a 5 on this side, and we're going to take away a 5 on this side. And you are left with x minus 5 equals parentheses y minus 2 squared. At this point, you have to remember how to unsquare something that's being squared. And that's where that square root symbol comes in handy. So we're going to take the square root of this side, and we're going to take the square root of this side. All right? So when we take the square root, here's what we're left with. Go down here. Oh, too much. When I take the square root of this, I'm left with y minus 2 equals. Now, technically, it's plus or minus the square root of x minus 5. But since I restricted the domain, it's actually just going to be the positive version of this radical. And I'll explain that in Desmos here in just a second. So now we're just down to our last and final step. We just add 2 to this side, and we add 2 to this side. So our inverse of this function, oh, I'll put g of x because I started with g of x. So the inverse of g of x is the square root of x minus 5 plus 2 when the domain was restricted to x is greater than or equal to 2. So let me type it in so you guys can see this, all right? So our inverse was the square root of x minus 5, and then it was, what was it? Plus 2. Plus 2. Now, what do inverses always reflect across? They always reflect across y equals x. Can you guys see how these are inverses of each other? Okay? That everything goes perfectly across the x, y equals x. They're reflected across y equals x. All right? X minus 5 plus 2. All right, there we go. Now, what would happen if I made this negative? Are these now inverses of each other? No. However, watch this. What if I change the domain and I put not x is greater than or equal to, but x is less than or equal to 2? Oh, interesting. So I want you guys to take note of this. All right? Take note of this right now. And we're going to put this in your journal. Check this out. This is our inverse. But if I said if our original domain was x is less than or equal to 2, then my inverse would be negative square root of x minus 5 plus 2. So if I had the original answer was what? This is the correct answer. But if I change my domain, if my original domain, remember, I'm going to put right here, if this was my original domain, that impacts what our inverse is. Does that make sense? All right, so if that was greater than or equal to 2, if I move that back and I put greater than or equal to 2, then what happens to this negative? It disappears. All right, let's go to our final one for inverses, okay? So our final one right here is dealing with a cubic function. We're going to do the same process here. We're just going to be solving for our new y value. So we're just going to add 7 to this side, add 7 to this side. We are left with x plus 7 equals y plus 3 cubed. And it's very similar to our square root. The only thing that's different is now we're not going to be taking the square root of both sides. We're actually going to take what's called the cubic root. So I got to put a 3 in the index, and I got to put a 3 in the index. So here's what I have. Here's what I have left. Okay. I have y plus 3 equals the cubic root. So that y plus 3 comes out equals the cubic root of x plus 7. And then you just take away 3 from this side and take away 3. So your final answer is the cubic root of x plus 7 minus 3. And notice, when you're dealing with cubic roots and cube root functions, you don't have to worry about restricting the inverse. Just make sure you put a 3 in the index. All right? So on the quiz, all right, on the quiz, you are going to have to find the inverse of a linear. You're going to have to find the inverse of a quadratic and an inverse of a cubic. So now you have examples for all of them. That took the longest. Now it's the fun stuff. It's the short, easy stuff. Okay, so we're just going to make it quick, short, and easy. I'm going to make 3 functions. I'm going to call one of them f of x. I'm going to call f of x just x squared. I'm going to call g of x. We'll just do x minus 4, and then we'll call h of x. We'll call it 2x plus 3. So there we go. F of x, g of x, h of x. Okay? And so what we're going to do is you might get a problem that says, what is... Here, let's do it one color here. What is h of g of f of 1? What is h of g of f of 1? All right? And so here's a quick little review of how to do this. You start with f of x, and what are you going to plug in there? You're going to plug in a 1. And what's 1 squared? 1. So now, what do we have? Now we have, what is g of 1? So what am I going to plug in here? 1. What's 1 minus 4? Negative 3. And I go, what is h of negative 3? So what number am I going to plug in there? Negative 3. So what are we going to do? 2 times negative 3 plus 3. So we got negative 6 plus 3, and the answer is negative 3. So what is h of g of f of 1? That's what? Negative 3. What do you always do when you guys are working with this? You guys remember doing this where you plug something in, you work from the inside out. Okay, so that's going to be dealing with this composition of functions. All right? Now, the last thing that you could possibly have with this is this last piece, which is this. Check this out. What is, ready? What is h of f of x? What is h of f of x? So we're going to take a look at this. What does this mean? We're taking f of x and we're plugging it into h of x. So if we look back up here, h of x is what? 2x plus 3. So I'm going to put equals 2 open parentheses plus 3. And what am I plugging into that? Of those, I'm plugging in an x squared. Yeah, so my final answer would just be 2x squared plus 3. Some of them will, not all of them. Okay? So how about this? What if I said, what is f? This is the last problem, and I'll let you guys begin. What if I said, what is f of h of x? So we'll do f of h of x. This will be our last one. So f of x is what? X squared. Okay? So something, what? Something squared. Well, what is h of x equal to in our particular circumstance? 2x plus 3. So what am I going to do? I'm going to take 2x plus 3. And what do I have to do to that guy? Oh, man, I got to square it. Oh, well, no. I forgot the FOIL method. That's okay. That's why we're doing one little problem dealing with the FOIL method. Do you think you'll have to do one of them dealing with the FOIL method? I don't know. Depends on what Mr. DeMood was doing that day. Most likely, yes. So 2x times 2x is 4x squared. 2x times 3 is 6x. 3 times 2x is another 6x. 3 times 3 is 9. So what would be our, quote, final answer for what is f of h of x? You would say 4x squared plus 12x plus 9. That would be the final answer for what is f of h of x. Okay? So the main, hey, this is going to be over operations of functions and inverses. Okay, what are your three inverses? Linear, quadratic, and cubic. What's your operation? Either you're plugging in a number or you're what? You're plugging one equation into another equation. That's it. Y'all have a good day.